In this talk, we're going to address some methodological issues concerning tonal development in young children. I'll be the sole presenter today. I'm Joe Stemberger from UBC. There are two co-authors on this, and I'll introduce them in a second. We'd like to discuss some factors that influence fundamental frequency and that we think might well interact with tone, and present some preliminary data from two children, each speaking a different language. Our primary concern is practicality, which is, in order to do a good job looking at tonal development, what should we be paying attention to? The two studies that are involved are general studies of phonological development, in which children, it turns out, have relatively low accuracy of tone around age 3. One of them is Valley-Zapotec, work with Mario Chávez-Péon. There are two level tones, high and low. There are also two contour tones, a falling tone, which is high-low, and a rising tone, which is low-high. Akan, and this data is based on Wendy Amoako's master's thesis at UBC, has two level tones, high and low, and some complexities that could lead to problems in acquisition. The map here shows where these languages are spoken and where the recordings took place. San Lucas Cavini in Oaxaca in Mexico is about right here, and then crossing the Atlantic Ocean. Akan is spoken mainly in Ghana, and the children were from Kumasi, which is the capital of the Ashanti region. Now, tone is usually described as being based solely on the fundamental frequency, but in fact, there are other predictable non-contrastive differences relating to vowel duration, amplitude, globalization, and so on. There's evidence for the past 30 years that these other factors can be used as cues if you remove or neutralize fundamental frequency, but retain segmental information. You get trading off which cues are being used, and you get shifts of boundaries. Now, that brings us to the nature of categories, and I just want to expand on kind of the modern view and where that takes us. The IPA gives sort of a perfect center of a phonetic category, but it doesn't tell us what cues are relevant to it, and it doesn't define the location of boundaries between the categories, which actually probably vary from language to language or time to time. Categories are structured somewhat in this way. Each of two categories has an adult range of variation. There's a boundary between them, and around the boundary, adults produce relatively few tokens. Children don't necessarily respect the boundary in quite the same way. They can produce tokens that are within the category but beyond the adult range of variation, or in some cases, perhaps not produce a difference between the categories at all, but we adults impose a categorization on the basis of where it falls relative to the boundary. Crucially, boundaries are not set once and for all. They can shift. They can shift for functional reasons. So for example, with a word like boil, there's no corresponding word with a P, which is poil. And if you have a token which is near the boundary on the P side, the boundary can shift to hear that as a B so that a real word is heard. In different phonetic environments, the boundaries can shift, or phrased another way, there are multiple boundaries. So the difference in VOT is shortest for labials B, P, and longest for velars G, K. And as I say, the boundaries show up at multiple places depending on place of articulation. Presumably this is going on when we transcribe children. If something falls near the boundary between high and low, perhaps we expand the boundary in order to hear a real word or the target word or contextually appropriate word. If there's a shift in fundamental frequency due to something or other, perhaps our boundaries will shift. Now, one thing that affects fundamental frequency is vowel height. Each vowel height has different intrinsic pitch. So high vowels tend to have a relative high fundamental frequency. Low vowels tend to have a relatively low fundamental frequency for aerodynamic reasons. Tone languages show the same effect of intrinsic pitch. And this means that if you take a low tone in a high vowel like oo and compare it to a high tone in a low vowel like ah, the fundamental frequency is actually fairly similar. Now, adults still have a small difference in the direction that you'd expect from tone, but if a child constricts the F0 range compared to adults, the two things, the high and low tone, could actually have overlapping distributions. This has implications for tonal development in a number of ways. Research doesn't tend to address it. And so, for example, research by Wong and colleagues over the past 15 years or so have asked adult subjects to identify what tone they're hearing after they've taken child data and remove the segmental information, leaving just the fundamental frequency. Completely ignores the fact that there are multiple boundaries between categories based on vowel height in this particular case, very likely to lead to an increase in noise and even experimental artifacts. And it's potentially quite relevant for child speech perception as well, because the child may have difficulty sorting out what effects on F0 are due to tone and what are due to things like intrinsic pitch. It seems reminiscent of Ohala's discussion of the first formant effects due to vowel height versus nasality, and how a different weighting of what goes on with the height of the first formant can lead to unexpected changes in vowel height in nasalized vowels that you find in historical change, and also that you find in young child phonological development. Everything I'm talking about is something that a native speaker will have at their command, but often our transcribers don't know the language that they're transcribing. They won't know any language-specific redundant characteristics that for tone that isn't related to fundamental frequency. They won't know where the boundary is between high and low tone in that language. They won't shift boundaries for lexical bias. And if they're really paying attention to pitch, they might forget about the effect of intrinsic pitch and wind up with artifacts. So our question is quite simple. Do you get effects of intrinsic pitch in child tone data? And that would be operationalized as an effect of vowel height on the accuracy of tone. Do native speakers transcribe tones differently than non-native speakers because they have access to other cues? We're just going to look at accuracy as a measure. We initially started out looking at the types of mismatch as well. So high, when it's not accurate, could be produced as low or mid or falling or rising or whatever. We found that high tone doesn't affect the type of mismatch, at least not for these two children. So we're not going to look at that, but we are going to pay attention to vowel height for accuracy where we find an effect. In Valley Zapotec, one child just a little bit before she turns 3-0. I'm the transcriber of the tone, a non-speaker of Valley Zapotec, and my transcriptions are supported by Pratt. Tone was overall quite low in accuracy at 43%. If you look at individual tones, high tones are more accurate than low, which perhaps corresponds to type frequency in adults. Falling tone is better than rising tone, which also perhaps corresponds to type frequency. But falling tones are better than high tones, and rising tones are better than low tones. And that isn't due to differences in type frequencies. And it's surprising because contour tones are complex, and complexity usually means lower accuracy and later mastery. Now, not all children show this effect, but this is unexpected. And when we see it, we perhaps, I want to ask what other things might be relevant here. Looking at the level tones, it turns out that vowel height just doesn't affect accuracy of the low tone at all. So that doesn't seem to be important. But for high tone, there actually is an effect. The most accurate high tone is on low vowels. So why would that be? Well, two things that you could look at. The intrinsic pitch of a low vowel is quite low, which gives the maximum contrast with a high tone. Perhaps that's what leads to the better accuracy. The other way of looking at it is that high tones, high vowels have a high intrinsic pitch, which could interfere with and mask the high tone. And perhaps that's what is going on. For contour tones, we do have to actually think about diphthongs a little bit, because intrinsic pitch changes in diphthongs can resemble contour tones. In I, intrinsic pitch starts low and rises, like a rising tone. In ua, it starts high and falls, like in a falling tone. But it turns out that that didn't affect accuracy for this particular child. What we did find is that monophthongs were more accurate for rising and falling tones than diphthongs were, in a way that wasn't just reinforcement by the intrinsic pitch. And we found that the accuracy on falling tone was lowest in low vowels and highest in mid vowels. We found that accuracy in rising tones was lowest in high vowels. Now we can look at that in the following way. Contour tones are more accurate when the beginning of the intrinsic pitch for the diphthong is congruent with the beginning of the tone. So high vowels start with a high intrinsic pitch and a high tone and fall. Rising low vowels begin with a low intrinsic pitch and rising tones start with a low pitch. So what's happening here perhaps is that intrinsic pitch is sharpening the starting fundamental frequency and making the tones more accurate. In addition to that, they were more accurate in mid vowels than in other vowels, which is interesting because mid vowels have the neutral fundamental frequency for that particular child, and a falling tone starts above it and ends below it. There's no interference, there's no masking. And so maybe that makes it easier to get it right without that interference. We conclude that there's some effect of intrinsic pitch for Vallée Zapotec, but it doesn't really seem to be the main cause of the low accuracy in this child. The Akan child is just a few days older than 3-0, transcribed independently by Wendy Amoako, who's a native speaker, and by myself, a non-speaker. Our results are very comparable. Basically, accuracy was just over 50% in this case, so reasonably low, but accuracy was highest on low tones and lower on high tones. And when we broke it down by vowel height, we found that accuracy on the tone was highest for mid vowels, lowest for low vowels. Now we just saw that mid vowel stuff with the neutral fundamental frequency before. That's interesting. For the low tones, there's no interaction with high versus low, and same thing on high tones, no interaction with high versus low, high vowels. So low tones are worst for the high tone, low vowels are worse for high tone, they're worse for low tone, and we kind of expect something more nuanced than that. So an effective vowel height, but maybe not due to intrinsic pitch. When we compared the native speaker versus the non-speaker, agreement was actually quite good. So 92% agreement on the tone, and with no obvious effective vowel height on where we agreed and disagreed. But that was only when we were both transcribing a tone, which was only on vowels that really were of good quality. There were some vowels that were of marginal quality because they were voiceless, they were creaky, they were low in amplitude. And that's due to the children being uncomfortable with the situation and happens often enough. I, as a non-speaker, transcribed tone for none of those marginal tokens, but Wendy, as a native speaker, transcribed tones for 2/3 of them and reported that her percept of whether it was high or low was stable on second listening. When you look at whether or not the child was accurate in for those marginal vowels, accuracy was the same as for the adequate vowels. In fact, just slightly lower. And that means that the transcriber was not just automatically filling in the target tone and was not showing a lexical bias, but presumably actually was focusing on non-pitch related cues, which I as a native speaker did not have access to. And again, we found effective vowel height, but maybe not for intrinsic pitch. So where are we? Well, fundamental frequency has multiple determinants in adult speech. It creates potential ambiguities. We probably should be sorting out effects of intrinsic pitch, of vowel loudness, of other segmental effects. But intrinsic pitch does seem to have some effect. Maybe it's not the major one, but it does seem to have some effect. Mid vowels may be showing up with their neutral fundamental frequency, showing up with greater accuracy for tones. Intrinsic pitch may be sharpening congruent tones so that high tone is better on high vowels, low tone is better on low vowels, or perhaps intrinsic pitch masking congruent tones so that low tone is better on high vowels and high tone is better on low vowels. Whether or not this is an effect in the child or effect in the transcriber, we don't know. Fundamental frequency seems simple, but there are multiple determinants that needed to be sorted out by children in their perception and their production and by adult transcribers of those children. And perhaps it's not surprising that tone is mastered relatively late in some languages. Thank you in Akan, Valley Zapotec, and English, and acknowledgements. Thank you very much.